Does anybody want to tell Marissa what everything is?
Is it recording?
Yes, now it is.
Okay. Oh, what was the question?
Okay, so the question, Marissa, we did this already. Okay, but we'll do it again for you. So for each of the numbers, A, B, C, D, E, R, S, T, okay, and those are all x values, state whether the function whose graph is shown has an absolute max and absolute min, a local max, a local min, or neither a max nor a minimum. So you guys tell her what is A and why.
It is neither.
Right, it's neither because...
It doesn't have values to the left. It's not
And that it's not the highest or lowest.
Right, okay, good. So it's not the absolute highest or obviously lowest because this is. And then, spoiler alert, and then it's not a local maximum because there's nothing to the left of it to say that locally it's, yeah, okay. All right, so how about B?
Local min.
Yes, it's a local minimum because locally it's the lowest, it's less than or equal to any other y around it. What about C?
Local min. Local min.
Yeah, local min and local max. It is less than or equal to everything around it, and it's greater than or equal to everything around it. D?
Another local min.
Another local min. E?
Absolute
max.
And local max.
Yes. Okay, did you hear them? All right, R?
Local min.
Local min. S?
Local max.
Local max. T?
Absolute min.
Absolute minimum. Yay.
So absolute maximum and minimums are always local maxes and mins, but local maxes and mins are never.
No.
Or not always.
Because that absolute minimum wasn't a local minimum.
Because it doesn't
There
have
was
values to the right
of
of it. They're independent of each other.
Oh.
But you can have one that's both one or the other or neither. So yeah.
In statistics, we would call those mutually exclusive events. If anybody has a stats class, it's one of the.
We're here to
We don't
Very
have any
few-
room for stats
One
in our
of the-
schedules because this class is limited.
Yeah, this is the important one. It's okay. All right. Okay, sketch the graph of. Oh, I like this. And anybody who would rather do it up here may. You're just going to come up with your own graph. Nobody's has to look the same. Sketch the graph of a function that has two local maxima. This is sort of like a Latin thing. So you have a maximum, or the plural is maxima. Okay. So two local maxima, one local minimum, and no absolute minimum.
Question.
Yes.
So can cusps be maxes and mins?
Yes.
Okay. And corners can be
Yes.
maxes.
Mm-hmm.
Yeah.
Yes, go ahead.
It's true. Yes. You don't want to have your
Wait,
Sunday worst up
Is it
there.
very sign
Sunday
down?
worst.
Does it have to have only one local minimum, or can it have more than one?
With this
I
Two
want
local
to
maxima.
say, because it's being so specific, I want to say it needs to have exactly those numbers and things.
I have an idea of
What's
what
your say?
Did everybody sign their inspiration to the
She does.
videos?
Well, actually, it's the reverse thing. It's like you have to sign an exclusion, not an inclusion. So, yeah, is that, honestly, is anybody in here not supposed to be pictured on
I can get one of those. I just signed one of those for work too.
really? Where do you work?
Sonic Village.
Yeah, where is that?
It's like if you take 65 and go all the way down to like it's like it's up where like upriver and then that turns to
Well, now, wait a second.
There's no absolute minimum because there's no one set value that's
Oh.
lower than another.
So here's one thing that I should have said prior to you drawing the picture. You can have more than one absolute maximum and absolute minimum.
Okay.
So,
So
Does it say that?
You can make a relative. Okay.
Oh,
It could be the same.
because they can be the same value.
yeah. So you
Oh.
can have two absolute minimums.
You can't draw it, but it's yeah.
It's
You can't.
it's
undrawable.
Okay, so he has two local maxima. That's right.
one.
Two local maxima, one local min,
And then
How can we, there's one little thing we can do here to make it no absolute minimum, and I don't know if anybody's going to.
Asymptote. Asymptote.
Asymptote.
I don't know. What if
I'm spitballing here.
You
Does it have to be like a
derivatives not
piecewise
existent?
function where it jumps?
You can do
Yeah,
I don't understand
Well,
how
drawing
an
is-
x
I-
to the fourth.
And the
Yeah,
whole,
that's true.
him saying an asymptote's not bad. Here, you want to see what I was going to do?
Yeah.
I was going to just do this one thing,
Oh,
and
closed
and I was gonna maybe go. Oops. And okay, so let me put that back up. I was gonna maybe go like that.
Can anywhere on that line be an absolute minimum then?
No, critical value.
Anywhere on here?
No, on that little like downward slope.
Yeah.
Couldn't anywhere on there be like an absolute
But
minimum?
nothing's a zero. Nothing's a
But the lowest.
slope.
What would the actual? So let's say that this was 2 and this was 1. Okay, like where I just ended there. So, how close to 1 would you get?
Infinitely close.
Infinitely close, yeah. Like, is it 0.9? Is it 0.99? Is it 0.999? Because it's an open interval, you can't find an absolutely lowest point because on the real number line there isn't one. Okay. Or
You
like
could- yeah.
when Logan said an asymptote, you could have also, that could be the other thing that we could do there if that
Yeah.
did that.
You could do
Then
that.
again, there wouldn't be an absolute minimum.
Mhm.
Oh, wait, are you ripping on my crooked asymptote?
That's so
That
funny.
is really
How you
bad.
said that. It's, are you,
I'm ripping you a new one.
What's somebody do B?
Well, you did draw a
My
fold
crooked
entire
ass.
line.
What?
You did draw a fold entire line. He is ripping you a new one. Okay.
Yeah. This is why my son can't watch my videos.
You're welcome, CJ.
See if the yellow shows up.
Probably not.
I think it looks, it looks
It's kinda
dark there.
gold.
I mean, it's really light on
Yeah.
my screen, but
Mhm.
projector's not what it was a few weeks ago. You guys can't. Now I'm realizing why you're doing first quadrant things. I
Well,
think it's because that's what they did in the book, but you could draw an
Yeah.
entire. Okay.
It's just easier.
Should I go turn off my light?
Yeah.
Yeah.
Okay.
I was gonna get good as you have to walk into your video.
I was thinking that I shouldn't do that either.
Too late.
Let me see.
Seven.
Ooh.
Uh-oh.
This
Oh,
is
that's
soft.
kind
That's gonna work.
of... Yeah. Oh, I think it's the wrong color.
Oh, it's
Oh.
making you think outside of the.
Wait,
First quadrant.
Making you think
No,
outside
not
the box.
necessarily outside of the first quadrant.
I was trying to make another box.
Cusps
Could I-
still
They're-
be
they're
mids and
yes,
maxes.
but it's
I will
but
so
it's still only have. If you like, we have an open dot. It's like if the limit does not exist, but the limit not exist.
Oh,
you, like,
I
somehow
know.
have, like, if you put a jump.
I
yeah,
wonder
it's
if I
like
should say,
continuous.
let's assume it's a continuous function. It didn't say that it was a continuous function, but who knows? This is number 14 in the book. Maybe someplace it said, sketch a continuous function with the following properties. I don't think it did, but. Well, here's.
I guess... Okay, I guess I can't do cusps, huh?
Why not?
Because that would be the local or the a max and that's...
Did you dip down? Because if you didn't dip down, I would
Oh,
like
I
that.
have it. I have it. I have it.
Yeah?
I don't. I think.
Okay.
I think I have it.
So if I didn't dip down...
Yeah, if you didn't dip down, you wouldn't have made a min. You'd still have a.
Yeah, I guess so. So I can do...
There you go. That's where your derivative doesn't exist. but it is neither a max nor a min.
Okay.
That is one way to do it. I was thinking of something else. I'm gonna go look at Alex and see if it is.
Wait, I'm not
Okay.
I'm trying to get it.
It's gonna look kind of cuspy.
But that's okay, right? If it did look cuspy, that was still okay.
I guess.
Because it still would be a max.
No straight line down.
It has a slight curve to it.
We're pretending
Very
that it still
slight.
passes the vertical line test.
Yes, it does.
So now we ask the question. Let's start at the end because he was so careful to include these. Does C have 7 critical numbers?
Yes.
See, now already, now
I
let me
think I
go
only
to
see
this.
6.
Let's go to the 3 local minimum. Does he have 3 local minimum?
No.
No, because what does he still need to do?
On the other side.
Yeah, it needs to.
Just like curve it up with
Oh, no, that was not gonna work.
Whatever.
I thought I had it, but then I was just
Just like draw the whole
make a belly.
No. Doesn't? Oh no, I guess not.
Oh wait,
On the
okay.
others.
Ooh,
oh.
I had to switch.
Okay, now do you have 3 local minimum now?
I sure do think so.
You do. Right. 2 local maxima. Point them out. Right. Okay, yes, those 2. And then 7 critical numbers. Point to the 7 critical numbers, please. 1, 2, 3, 4, 5, 6, 7. Oh, he wasn't even looking. Yeah.
Why aren't the ones on the? Why aren't those ones
Critical
local?
numbers. Because does somebody else want to tell?
Oh, I was gonna draw it. So, because if you take the slope at that point,
Not that one.
well, which one? What are you talking about?
The one in between.
The third one is-
This one? Because you can draw the tangent like that, or like this, or like that, or
That's why the derivative.
with that, or that.
So-
or-
I think her
Yeah.
question is why isn't that a max?
Sort of local.
And it's not, but why isn't it?
Oh.
That point
Because it really wouldn't. Because at that thing.
this one it goes up. It's the point
Right.
it keeps going up.
These are like.
So it's not a max.
So the value of this
Just
right
the
here,
value on that.
the value, this is less than that, but this is higher than that, so it can't be
Okay.
the local maximum.
So
That's
if
why
it's
you
like
had to make the right side of that curve not dip down,
I understand.
or else it would be a local maximum.
I'm gonna in another color draw the only other thing he could have done. Did you guys? I wasn't listening. Did you answer the why it's not a max? Because there's something higher than it on the other side. Okay. The only other way he could have done this was on these 2 points where he made the derivative not exist. He could have had the derivative exist, but this way. This could have gone up. Actually, maybe I should have done right here. This is your critical number. The
Then point of inflection.
a point, yes, a point of inflection will have a derivative equaling 0. So your 2 extra critical numbers that it was hard to make. It was easy to make 3 and 2, right? 5 critical numbers were super easy to get because you had 3 mins and 2 maxes, okay? But the other 2 were hard to get, and the other 2 could have been from points of inflection, okay? And you made them from cornery things, and that was cool too. That was
I
good.
was thinking of doing like an X cube.
Yeah, right.
That would work.
Look at mine again.
I will. Okay, in the meantime, let's see what's next. And if you guys want to take a break, you can. If you want to start looking at that problem, you can. I think I'm going to pause this, or we're going to go like